Traveling to Mars takes about 7 months with current technology. In 2022, NASA's Perseverance mission reached the Red Planet within that period. The trip to the Red Planet took about 300 million miles or 480 million kilometers. But now, a space company aims to dramatically reduce that long travel duration. Believe it or not, whether they succeed or not, at least this technology could be a small step toward big results in the future. The quest to settle on Mars is closely tied to the incredible leaps in technology. With advancements in space travel, sustainable living, and resource utilization, the idea of colonizing Mars is not as far-fetched as it once seemed. From SpaceX to NASA, various organizations are investing in making the journey to Mars a tangible reality. So why do people want to settle on Mars? According to Elon Musk, a permanent colony on the Red Planet could sustain our species if all humanity is extinguished on Earth. UK-based startup Pulsar Fusion plans to use nuclear fusion to turn interstellar space travel into a reality. They have big plans. They want to significantly shorten travel time with its breathtaking fusion rocket technology. Pulsar Fusion has started construction on a significant nuclear fusion chamber in England. Their goal is to become the first company to launch a nuclear fusion-powered propulsion system into space. Fusion technology promises a power output that is 1,000 times greater than that of the conventional ion thrusters currently in orbit. Fusion takes place when two atoms combine. This results in the release of an immense amount of energy. Pulsar Fusion has ambitions to achieve a speed of 500,000 miles per hour with its fusion rocket. To note, the highest speed ever achieved by a crewed rocket is 24,791 miles per hour, and the unmanned Parker Solar Probe holds the record as the fastest spacecraft humanity has launched into space, reaching speeds surpassing 247,000 kilometers per hour. The startup claims a round trip to Mars could become feasible within a matter of weeks in the future. Their goal is to achieve fusion temperatures by 2027. The next phase involves conducting a test, firing in orbit. Everything is good so far, but the issue ultimately revolves around whether or not this is possible. With current technology, it is impossible to travel to Mars in a few weeks or reduce the 10-year distance to reach Saturn's moon Titan to 2 years. Today, a trip to Mars takes about 7 months. Take a look at the distance between Mars and Earth. The average distance is 225 million kilometers. Traveling at the speed of light, 300,000 kilometers per second, is currently considered impossible for objects with mass. As an object with mass accelerates, its relativistic mass increases, and the energy required to continue accelerating it approaches infinity. This means that theoretically, it would take an infinite amount of energy to accelerate an object with mass to the speed of light. If we consider hypothetical scenarios and ignore the limitations imposed by our current understanding of physics, we can use this formula. Let's assume the average distance between Earth and Mars is around 225 million kilometers. If we use the speed of light in a vacuum, the calculation would be: the result is approximately 750 seconds or 12.5 minutes. Remember that reaching a speed close to the speed of light is required to achieve such a journey. Please note that this calculation is purely hypothetical and does not consider the practical impossibility of reaching or exceeding the speed of light with our current technology and understanding of physics. The actual travel time to Mars with current technology is several months, depending on the specific positions of Earth and Mars in their orbits. But what I emphasize is that the output of the nuclear fusion technology, even if it fails to bring us to the Red Planet within a few weeks. Developing nuclear fusion technology for interplanetary travel could lead to several technological achievements. Spacecraft equipped with fusion propulsion systems could achieve much higher speeds, reducing travel times to distant planets like Mars. Fusion-powered spacecraft could operate for extended periods, enabling longer duration missions. Fusion propulsion systems could allow for larger payload capacities, enabling the transport of more equipment, supplies, and scientific instruments to very distant places. This technology also offers a more efficient energy source compared to traditional chemical rocket fuels. This could result in spacecraft that require less fuel for the same amount of energy. If you enjoyed this video, do not forget to hit the subscription button. Make sure to click the bell icon so you never miss an update. Until the next video, keep your eyes directed towards the sky.